Now in this video, we're going to do learning objective F. We're going to compute arc length of a circle using degrees or radians. Now in geometry class, you actually did arc length. All arc length is if we were to draw a circle, and then if we move on the circle, let's say they go 100 degrees. If we move 100 degrees, we just created and sketched the length of the arc. So the question is going to be, what is the distance, or how long is that? That's what arc length is. Well, what you can do is it's really circumference. So all they did back in geometry class was took the formula for circumference, which is 2 pi r, and they said, you know what, give me a portion of the circle. If I want the full circle, I'm just going to do 2 pi r. But if I don't, in this case, if I just wanted 100 degrees, what I would do is put 100 here and do the formula. So you can always go back to the geometry method. But there is a shortcut you can use in trigonometry. What you can do is, it's a very short formula. You're going to put r in here, which is the radius of the circle, but here you do what's called theta, and all you do is put the radians. So if we knew how many radians 100 degrees was, and I'll tell you it's actually going to be 5 pi over 9 radians in terms of pi's, all you have to do is you put that into here and you plug in the radius, and you'll get the exact same answer as if you use a geometry method. Now let me just show you real easily why this formula actually works. It's very simple and easy to prove. 2 pi, if we were to say how many degrees 2 pi is, we know we could say it was 360 degrees. So I'm going to replace that. So if I'm going to take this formula here, I would say it's my degree over 360 times, instead of 2 pi, I'm going to put 360 degrees and keep the r there. Well, what happens here, folks, the 360 cancels out, and I'm left with this theta times r, which is this formula here. So all you need to know is there's a trig formula we can use if we have the pieces of pi. There's a geometry formula we can use if we have the degrees. So what if they gave us this example? Find the length of the arc of a 50-degree central angle in a circle with a radius of 6 feet. Well, I might just go the geometry method here and say circumference is 2 pi r. So 2 pi times the 6 feet. But I have to be careful here because this is for the complete circle. I don't want the complete circle, I just want 50 degrees of the complete circle. Fine, give me 50 degrees of the full circle, which is 360. If you simplify this out, what you're going to end up getting, now if we simplify this out, let's see what we could do. I'm going to cross off those two zeros. And then let's do this. I'm going to do 6 times 5 is 30. I'm going to keep the 2 pi there for a second though. And then I'm going to continue to simplify because this is really just one big fraction. Why don't I say 2 divided by 2 is 1, 36 divided by 2 is 18. So that would leave me with 30 pi over 18. I can simplify this further. I can simplify this further by pulling a 6 out of each. If I divide this by 6, I get a 5. Here I get 3. So 5 pi over 3 is the arc length. So that's this right here, but it's in feet. This is kind of hard to visualize, so what you might want to do is take 5 times pi in your calculator and then divide it by 3. If you do that, you're going to get approximately 5.24 feet. You can visualize this arc length here is actually now 5.24 feet versus looking at it in terms of this, which might be harder to interpret. Now in this example, they want us to find the arc length, but this time they've given us the radian. So why don't we use that shortcut and just take the radians times the radius. Let's actually sketch this first. 5/18 of a pi, again, this is 1 pi, imagine that in 18 sectors, and I want 5 of those. So there's 18 sectors, this side has 9, this has 9. If I want 5 of those, maybe the arc length would be something like right here. So they want to know that distance. So all I have to do is put the radians in here, so it's 5 pi over 18 times the radius of 6. If we simplify this, just go straight across, 30 pi over 18. Again, I can pull a 6 out of here, which will give me 5 pi. 6 out of here, which gives me 3. and we get 3 pi over 5 is the exact length in feet. Again, it's hard to visualize, so just do 5 times pi divided by 3. You're going to get approximately 5.24 feet. Now you should notice these last two examples have the exact same answer, and here's the reason why. If I take these radians, by the way, let's convert it to degrees really quickly. 5 pi over 18, remember pi is just 180 degrees, so I'm going to do a quick shortcut. What you're going to notice here, the answer is 50 degrees. So what we did is we really did the same question. The first question we used the 50 degrees. This one we did the radians. So they're just showing you can get the exact same answer in two different methods. Let's wrap it up with this example. Swing hangs from a chain that's 8 feet long. So we see the length of the chain right here is the radius of the movement. How far does a seat travel if it moves at an angle of 1.25 radians? Now, this radian movement doesn't have the pi's, so it's how many radii it moves. So that's about 1 radius and another quarter. So they want to know that distance or the length. Well, they gave us radians, so the shortcut formula is take radians times radius. It's actually a very easy question. So 1.25 radians times the radius. If you multiply this together, you get 10 feet. So knowing the shortcut formula makes the problems when they give you the radians much easier than going back and trying to do the geometry method, because for geometry we would have to figure out how many degrees this is and do 2 pi r and then take a portion of those degrees. So knowing this formula can really help save you some time and anguish.